Welcome to the last video in the circuit protection series. This is the last of 3 videos covering 3-phase protection devices, and so far in the other videos we've been looking at protection devices for short circuit protection, under voltage, over voltage, overload and overheating, loss of phase, phase reversal, and auto restart. Now we're going to have a look at some tables and the selection of some protection devices and how we'd go about that. So we have here a table of circuit protection devices and potential faults. We've got short circuit, overload, locked rotor, phase failure and phase reversal, and the protection devices are circuit breaker, thermal overload, magnetic overload, thermistor, phase failure relay and phase reversal relay. So we're going to make some choices here of what sort of equipment we're going to use to protect against these different faults. So the first one is short circuit, and what are we going to choose? I think a circuit breaker would be a pretty good choice for a start for dealing with short circuits. That's what they're good at. They have the magnetic latch mechanism in them that operates when lots of current flows. Some people might say a thermal overload or a magnetic overload might also do that. Probably they're not designed specifically for short circuits, and both of them may even be damaged if we have a short circuit. So we need some better protection upstream, and for short circuit protection I think the circuit breaker is the one to. So now we're going to look at overloads and what we would choose to protect a motor from overloads, and the first one would be thermal overloads, of course, made to do the job with its 3 bimetals. Then the magnetic overload, which monitors the current with the coils and uses magnetism to trip if there's an overload. Then there is a third choice, which is thermistors. Thermistors don't monitor current, but they do monitor the temperature of a winding in the motor. So if there is an overload, the windings are going to get hot. If the motor's working too hard, then the thermistor will notice that and send a signal to the control equipment to shut that motor down. The one advantage of thermistors is that they're going to notice temperature rise for whatever reason. There might be blocked vents in the cooling of the motor or something along those lines. The thermistor is still going to pick that up. The disadvantage of thermistors is they're difficult to test to see if they're actually working. You'd have to heat the whole motor up and monitor the thermistor, so that is an issue. The other thing is that they are susceptible to being insulation resistance tested, and you can blow them up, and if they are broken, it's difficult to replace them. You have to get into the windings of the motor. You probably need to send it to a motor rewinder. The advantage of the bimetal overload is that it's, as we said before, it doesn't need special timing equipment to stop it from tripping out on motor startup, and it's simpler, it's cheaper to make, it's less to go wrong in there. The disadvantage is it has to cool down before you can reset it, and if you can imagine yourself in a factory huffing and blowing on a thermal overload to try and cool it down to get the factory going again while the workers stand around and look at you, it's probably not a good plan. If you're in that situation, you probably should spend a little bit more money on a magnetic overload. Magnetic overloads are able to be reset instantly. The downside is that they're a bit more expensive and there's more inside them to go wrong, but that might not be a problem if you have a whole factory to think about and the production to look after. The next fault is locked rotor, and really it presents the same issues as an overload. The rotor of the motor for some reason has been jammed and locked. It's not turning. There's no back EMF being produced in the motor, and so it heats up like there is an overload. So you can also tick all 3 of those for a locked rotor, and the same things that protect from overload. Right, next we have phase failure, and no prizes for guessing which protective device we're going to use for that. Yes, you're right, phase failure relay. Brilliant. If we lose a phase and that's going to damage our motor, this protection device will shut the motor down. Okay, what's next? Phase reversal. No prizes here either, is there? And there's one protection device, the old phase reversal relay. If there's a reason that we don't want the motor to go backwards, if it's really important that the motor doesn't go backwards, if it's going to produce a dangerous situation, then we can use one of these relays to stop that from happening. So there you have it. There's our choices for protection devices for the different faults that we've got on this chart here. That brings us to the end of our series on videos on circuit protection.